Welcome back to Math 107 College Algebra. In this video, we're going to take a look at solving quadratic equations by completing the square. Now, this may be a little bit different than what you're used to seeing with completing the square, because we're going to use the method for completing the square from transformations that we saw back in section 3.3. So I'm going to work on the equation x squared plus x plus 1 equals 0. So the first thing we're going to do with this is we're going to find the vertex of that equation. So we know the x-coordinate is minus b over 2a. So that's going to be minus 1 over 2 times 1. Then the y-coordinate is going to be our f of that. So f of minus 1 over 2. And by that f, we're meaning what we have on the left-hand side. So that's going to be minus 1/2 squared minus 1/2 plus 1. So 1/4 minus 1/2 plus 1. And if I simplify that down, that comes out to 3/4. So our vertex is negative 1/2, 3/4. So that's going to make our new equation x minus 1/2, which I'm going to call plus 1/2, squared plus 3/4 equals 0. So now we can go ahead and subtract 3/4 from each side. And then we can go ahead and take the square root of both sides of this equation. Being careful that when we take the square root, we need to include plus or minus. So we have a negative underneath the square root, so the first thing we need to do is factor that out as an I. And I'm also going to apply a rule that you might remember from previous algebra courses. I can write the square root of 3/4 as the square root of 3 over the square root of 4. So now in the next step, I can simplify the square root of 4. So I square root of 3 over 2. And now we can subtract 1/2 from both sides, and we get x equals minus 1 plus or minus I times the square root of 3 over 2. So that's how we solve a quadratic equation by completing the square using the alternative completing the square algorithm that we got using the transformation idea. What we're going to look at in class on Friday is a way that we can just derive a formula to solve quadratic equations in general without having to go through this process.